everyone to this workshop at AECtech that we're titling Beyond Geometry, and specifically crafting new workflows with Grasshopper data for Rhino8. We're excited to really host this or kick this off because, to be honest, we've been working on these new set of components for Grasshopper 1 for a little bit over a year and a half. I say myself and Kike are the main developers of these tools internally, and we have shown this off, on Discourse and at a couple presentations, but this is the first workshop where we're really covering these in detail, or there was one last week. So you guys are sort of the first to kind of go through this demonstration and this presentation, and so we're really excited to get your feedback and see what works and what doesn't work and what we can fix. But we're really excited to show you all of the new tools. So to give you an idea about the agenda, we're going to first introduce myself and the topic. I was going to give a relatively quick presentation about what these new data types are, how they work, why we need them. And then really the bulk of the workshop today is going to be a hands-on demonstration. Hopefully each of you have some familiarity with Grasshopper. That will be helpful. Some of the stuff what we're going to cover today has been distributed. I've tried to break it out into specific files that we'll kind of go throughout the day and build upon. But some of that's already been pre-built for you, and then some of it we will be building from scratch. Most of what I try to do is either set it up so that all the time-consuming parts that are just sort of general Grasshopper components and things like that have already been sort of bundled in a cluster, whereas all the new stuff that deals with attributes and new data types and things like that I've left exposed so that we'll build those from scratch. And at the end, we'll try to save as much time as we can, hopefully about 15 or so, or maybe even more minutes for Q&A. So if you have any questions, you can either save them to the end or feel free to type them into the chat, and either Sila and or Jaffe can field some of those questions for you. But honestly, this is fairly informal. I'm totally happy if you want to just stop me if something doesn't make sense and ask the question to the group, and I will try to answer it as well. So a little bit about me. I started at McNeil a little bit over 2 years ago, October, actually, this month. So I've been at McNeil for about 2 years in the North American office. I hold a doctoral degree from Harvard, as well as a master's degree from Columbia and a bachelor's from Clemson University. I am also a licensed architect. A lot of the developers internally hold sort of architectural degrees or design degrees, and that I think gives us a little bit of unique insight as we develop the tools. But obviously we rely on feedback from each of you as to what we can do better. And on that, many of you have probably, including myself, who has been a diehard Grasshopper user from probably the very beginning, have noticed just how the breadth and width of all of the different types of components that are available in Grasshopper. And not only that, those are expanded upon by third-party developers who make their own custom set of tools. So there's probably hundreds, if not thousands, of components that are available in Grasshopper 1. And it's amazing. It really hats off to all of the developers, and mostly David Rutten, who was the creator of Grasshopper from early days, for all of the work that has gone into all of these different components. But if you used it for any significant amount of time, you may have run into one or two issues where you notice that there's maybe a gap in the existing tool set, that it's not quite complete. Most of the stuff is there, but it's not maybe quite as complete as it could be. And for example, Grasshopper 1 has no notion or understanding of what a Rhino layer is, or a Rhino material for that matter. We don't really have ways to create or modify Rhino materials or native annotations. There are a limited set of annotation tools for display purposes only, but having the full set of annotations that Rhino offers available in Grasshopper has been limited to non-existent, as well as blocks and any number of other data types that have been around for a long time in Rhino, but just for whatever reason never really made its way into Grasshopper. Grasshopper has primarily been used for geometry creation, and then it's been left at that. And anything you needed to do for documentation or materials or rendering or layer management, you had to then do inside of Rhino. You had to bake the geometry and then manage those inside of Rhino. And so what we wanted to do with this project was to try to fill some of those gaps. And so we set out to create a whole bunch of new components that really represent new data types. Here are just a handful of icons for some of those new components. There are over 100 new components that are available in Rhino 8 that are not available in Rhino 7. So there is a break there between Rhino 7 and Rhino 8 in terms of the types of components that are available to the user. And so I'd like to kind of cover a little bit of information about how these new components work before we really jump into using them. And one thing we needed to know when we started developing this was that there was a existing pattern of a constructor / deconstructor method. And what I mean by that is, let's take, for example, a point object, right? We have a point, and from a constructor standpoint, it has 3 inputs, and then it constructs a point, which we can return as an output, right? And then we have a second component, which we had called deconstruct point, which takes in that point and then retrieves the individual attributes or the individual elements of the XYZ components. And while that's been really efficient and as a mental model is very clear as a constructor deconstructor, we were a little bit concerned because it bloated the Grasshopper ribbon. We now need 2 components for every data type as a constructor and a deconstructor. And it also sort of took up a lot more space, right? Where we now have 2 components where 1 might suffice. So what we decided to do was kind of rethink the overall structure here of how these components work. And we're calling these pass-through components. And they're pass-through because you can still have the 3 inputs, which let you control the XYZ coordinates and get those, get a point object out. Or you could pass in a point and deconstruct it into its individual elements, right? So that you pass in a point and you have the XYZ coordinates on the output side. If you decided you wanted to make one change to any one of those coordinates, you can still pass that in as an input, and it will take all the existing coordinates that you haven't changed and then only replace the input that you did change. So in this case, we changed the 4 in the Y coordinate to an 8 and left the other ones the same. And now we have a new point at 2, 8, 6 instead of 2, 4, 6. And so these pass-through components, they all work pretty much the same way in that the first input and output always relates to, say, the data type, right? In this case, we're talking about a point, right? It's very easy to understand. X, Y, and Z creates a point. So the main data type is a point, and the attributes that make up that point are its X, Y, and Z coordinates, right? Now, a point component, the constructor deconstructor that I showed earlier, has been used since the almost earliest days of Grasshopper, and we didn't want to introduce a new point component and confuse existing users or also mess up existing files. So this example I'm showing here on the point is really just an illustration. There is no new point pass-through component, for example, but there is, for example, a new layer, Rhino layer, model layer component. And it works the same way in that the first row of input and output always represents the main data type, and then the inputs and the outputs really describe, underneath those, describe the number of attributes. So what is an attribute for this? And really an attribute is anything that makes up an existing data type. And so for a layer, if you look at the layers panel in the Rhino, you'll notice that a layer is defined by its name, its visibility, its display color, its line type, its material settings. So all of those different settings define what a layer is in Rhino. And so in Grasshopper, we have the same idea where we have a layer as our main data type, and then underneath are all of those same settings that you see in the Rhino panel is now available inside of Grasshopper. And so let's look at an example. Let's say we wanted to create a new layer in Rhino, we'll give it a name called geometry layer, and we give it a display color to be blue. Okay, simple enough. So we have this new component, and you can see on the output side of that very top output that we have a new layer that's called a geometry layer, and it has an attribute called display color, and it's the blue color, RGB. Now, I don't know about you, but that's a giant component with a lot of inputs and outputs. And so all of these pass-through components have this new feature, which lets you right-click on it and hide or show any of the unconnected parameters. So right now, we've only defined the name and the display color, but all of the other settings have been left untouched, right? And so we're not really concerned with its hidden visibility or locked state and so on and so forth. So if we say hide unconnected parameters, it will then minify or shrink the component into only the inputs and outputs that are necessary. And then it gives you a much smaller, compact view of that component. So then we have we've introduced a new component on the far right. This is the model object attributes. This is where we assign attributes to an object, right? So that could be a name, what layer the object is on, is it visible, so on and so forth. So in this example, we have a sphere connected to the geometry. So we're gonna assign these attributes to a sphere object. And in this case, we're going to tell the sphere that we want to put it on a new layer called geometry layer, and whose display color is blue. And so if I right click on the model object attributes component and say bake, the way you have been baking forever, you can then see that it bakes a new sphere that has inherited the blue color because its display color is by layer. And the layer is also created a new layer in the layer panel called geometry layer. And so with this new setup, particularly this object attributes or model object attributes component, you really have a lot of control over how you assign attributes to objects, geometric objects in the Rhino model. So first, you can assign the geometry itself. You can give it the name. You can assign a layer, and each of the layer attributes can be defined through the layer component. Same thing with visibility. You can control whether it's going to be hidden or locked or not. You can control the display attributes, and each of those have its own components, like the display mode. You can define whether you want a component when it's baked to always show in rendered mode or shaded or Arctic mode, for example. Similarly, with drafting, you can set all of the drafting attributes like line type, line scale, print width, or print color, and then set some of those like the line type attributes, as well as rendering attributes. And again, each of those have its own set of components. So there's really a lot of control over how you can assign attributes to an existing object in Rhino. But we didn't want to stop there. That's really powerful and already lets us do a lot of things. But as I mentioned in the intro, we also recognized that there was a missing need for annotations. And so not only did we add full support for all of the different annotations that are available in Rhino, so radial dimensions, center marks, linear dimensions, text entities, leaders, so on and so forth, but we also created a set of components that let you define annotation styles, right? So if you're used to using annotations in Rhino and also being able to control all of the annotation styles, like the arrow size, the text size that you see on annotations, all of those different settings can now be controlled parametrically through Grasshopper as well. So just as a very quick example, now you get to see your parametric drawings come to life with these annotations. These are real Rhino object annotations. When you bake them, they come in as Rhino object annotations. You can change this global scale, as well as just, I'm quickly here querying my model for the different annotation styles that are there. So in this case, I had 5 different annotation styles in this model. And as I move that slider, I can quickly see what those different annotation styles look like on a particular model, just by changing the slider and assigning a different style to that. So this has a lot of opportunities, I think. Here you can see that where I'm switching through the different annotation styles. We also, besides annotations, but in the same vein, we wanted to look at hatches. Hatches have been somewhat available, but not really available in earlier versions. Now we have full support of hatches and how you control them, as well as some new line type and line type preview components in Grasshopper. So as a really quick demonstration of this, I've got a little 3D widget that I created through Kangaroo, which lets me move 2 points around in a RGB space. And depending on where those 2 points are, it lets me just control the overall color gradient between on my hatch. So nothing really fancy there, but here you can see again, I have a query where I'm querying the various different hatch styles that I have, hatch patterns that I have in my Rhino model. And I can quickly change the overall scale, the rotation, which hatch I'm using, you know, the repetition of the gradient and the color. So you really have full control over hatches now within Grasshopper. Another thing that we're pretty excited about that is new in Rhino 8, if you've been trying to create custom drawings in Grasshopper, is being able to control line types, right? It's been really frustrating to be able to control line types in Grasshopper to create really unique drawing styles. But now we can assign custom line types. These are Rhino line types that you can bake into your model, but that have, you know, dash settings. We have new abilities to control the taper. So you can control a taper position along the length of the curve and its width. So we now have a lot finer control over how lines are displayed in Grasshopper. And so putting all those together, you can make drawings or models that are fully parametric like this. This is all done in Grasshopper, where you're changing the annotation style, the annotation size, the hatch patterns. Everything here is a 2D representation. Even though I'm drawing shadows, those shadows are all done through hatches with some transparency. So here you can see I'm just modifying a different hatch in a boundary. And so it really lets you have a fine-grained control over how your drawings look in Grasshopper. And then of course, because you're controlling them in Grasshopper, you also, and when you bake them, they also come in fully controlled and baked into Rhino when you bake it into your model. We also wanted to enhance the ability to control blocks, which, to be honest, have been non-existent up until now, right? Blocks are really useful and are used a lot in Rhino, but we just haven't had that ability to do anything with them inside of Grasshopper. So here you can see we have some geometry that we want to make a block out of. This is a very simple example, but all it is a quad panel configuration. And I can control the sort of height and X, Y, Z coordinates of this panel system. And if I have a block, I can make a block definition of that object. Here you can see when I bake it, it has a name called panel A. And now if I change that geometry in some way and then bake again, what happens is I've just updated that existing block. It's not creating a duplicate. It's not creating a new instance of, so every time you bake it, you get 30 different block definitions. Instead, it's just looking for the block definition named panel A. And when I bake it, it's going to update that existing block definition. And then let's say I now have 4 different block configurations, panel A, B, C, and D. And I've got another little cluster which helps me generate a random grid. Here I can use a query component to bring those 4 definitions, block definitions, into Grasshopper. And then I can use those block definitions to create instances of those blocks. So here you can see, just using a grid, I'm using those 4 different definitions and assigning them to different positions. And then again, like I said, I can bake those, and now those become block instances in my Rhino model. So again, now you have control over blocks and how they're created and distributed throughout a Rhino model. Let's see. Second to last. We also wanted to add some support for user text. I'll be honest, I didn't use user text a lot in Rhino up until a few years ago, and I'm kicking myself because of how powerful I now understand user text can be. essentially, if you've never used it, user text is metadata, key value pairs. It can be anything you want that gets assigned to geometry. And so we've not only created the ability to create that user text on objects, and it doesn't even have to be geometric objects. It could be layers or materials or anything like that. But we also now have some components that let you filter or group. So for example, let's just say we wanted to assign some user text to these panels. I simply create the user text component, assign the keys and values, and when I bake it into my model, you can see that now each one of those panels has a key value pair, a set series of keys, values, and pairs that represent its ID, its cost per square foot, and its manufacturer. And they're all unique. So a yellow one knows it's a yellow panel, a blue one knows it's a blue panel. It knows the cost per square feet. So now every time we update that or bake it, it will then update that user text information. But let's say we had an object that already had some existing user text. So here I've got a bunch of objects. They're just randomly coming in as an unordered list. We have some components. In this case, it's called a group by filter. In this case, I want to group by the manufacturer, for example. And now once I use that, you can see all of the yellow panels get grouped together, or all of the zinc panels get grouped together. And so it's grouping them by manufacturing, but you can really group these by any number of variables, whether that's the material color or the layer name or anything you can imagine. You can start to group content. Similarly, you can create filtering rules, and you can even join those up into really complex filtering rules. But in this case, let's say we wanted to just filter out only the panels that have the word yellow in them, right? So I'm using a contains filter to look at the ID, the user text ID for the word yellow, and now it returns only the content that has a user text ID with the word yellow in. So again, some really powerful new tools for managing data inside of Grasshopper. And lastly, and maybe most importantly, is a baker. Now, if you've used it, I've already shown a bunch of different ways of how you can right-click on an object and click bake. But there's a new component, this dynamic baker, which I'll show, which has a single input called content. And in short, it basically lets you bake any type of data type that we've just talked about. It can bake layers, it can bake line types, it can bake annotation styles, including all of the geometry that we just talked about. So let's look at a quick example. Let's say we had a circle and we wanted to bake that into our Rhino model. You can see it has a button on the bottom that says update. And when I click on it, it bakes that geometry into our Rhino model, and now I can go and select it. If I move my slider, you'll notice that our preview changes, but until I hit the update button, it doesn't bake the geometry directly into our model until we hit that button and manually update it. But we didn't want to stop there. You can zoom in on this component and click the plus button, and now you can have an input with a Boolean toggle, which lets you input a true or false value, and it will automatically bake the geometry into your model every time you make a change. So already something that's really powerful. But there's two different modes in how to bake it, and they work kind of differently, so I want to mention this in particular. The first is insert mode. Insert mode works exactly the way Grasshopper has always worked, in that every time you bake, it's going to create a new duplicate geometry in your scene, right? So every time I'm changing that slider on each solution exploration, it's going to bake a new piece of geometry. And so here, by changing that slider, I've got 5 new circles in my scene. But there's also the update button. And what that tries to do is it tries to track objects that it's already baked or has a reference to. So now instead of inserting one every time I move my slider, now it's simply just modifying the geometry each time it gets updated. And that, again, can be updating user text, updating attributes, updating geometry. So it's trying to be really smart and keep track of what it's already baked and know what to update each time it needs to bake. Lastly, there is this feature that lets you release the content. Let's say you wanted to have an option, you're happy with this option, but you want to keep exploring things you can release the content, which essentially means stop tracking this particular object. And now when you move the slider, it's going to start tracking a new object, but it's already baked that last one. So that one that was released content is also now in the scene. So there's a lot of really new features, and we're really going to cover a lot of these today. That's why you're hopefully taking this class. So there's a new, once you've installed Rhino 8, there's a new Rhino tab in Grasshopper, which is where most of those new components that I just described live. And we're going to continue adding as many as we can to that new category. But before we jump into the workshop, are there any questions about any of the stuff that I just covered? Anybody? Feel free to unmute yourself and just yell out a question if you need to. No? Okay. Oop, I don't think I meant to stop sharing. Let me. There's.
I have a quick question.
Okay.
So I know there's been a lot of discussion about blocks being able to have consistent properties and changing the properties. So let's say like one block definition, a point could be variable as part of that block, or it's like dimensional, having dimensional constraints. Is that incorporated into Grasshopper at this point? Like you could bake multiple instances of the same block definition, but they might look different. Does that make sense?
No, I don't think, I know what you're saying. And yes and no.
Okay.
There is a new feature that's letting you, that we're actually rolling out today, or before next week's build, which so we're not going to cover it today because it's not in the build that you guys have. But it lets you bake in batches. So you could theoretically have batch A, B, and C, and A has a certain configuration, B has a certain configuration, and C has a different configuration. And when you bake those, you can tell it you want to bake this series to batch A, this one to batch B, and this one to batch C. And it's smart enough to know how to manage all of those blocks. So you're essentially creating, 3 different options, 3 different instances of these different block definitions. So that's one way, but I think really what you're talking about more is specifically about constraints, like family parameters, I'm assuming, in Revit. And that's not available, but it is a new project that was started in Rhino 8, but we decided to pull it and explore it more in Rhino 9. So there is a project called Constraints that sort of deals, it's quasi using a physics solver to do the constraints. And I think once we get that in, which will probably be more like Rhino 9, but once Constraints gets more embedded into Rhino, then I think you'll be able to do the type of stuff that you're talking about. So that's why I say yes and no. So with batching and stuff like that, I think you can create different options and with different configurations that hopefully will kind of get to what you're looking for. But also, I think there's probably more that we can do with constraints, if that makes sense.
Got it. Thanks. Got to wait till 9 then.
I wouldn't wait too long. I think there's a lot in Grasshopper 8, or Rhino 8 and Grasshopper that is pretty compelling, at least in my opinion. All right, so hopefully everybody got the files. Everybody seeing my screen still? See Rhino?
Yeah.
Okay, great. So hopefully everybody also downloaded the Rhino files that I sent. And so what I'd like to do is start by opening the Rhino file called column grid base. And pretty much this is empty. There is nothing that's really that important. We could have just used a new template. The one thing I want to mention is that by default, if you use no template or whatever, you create a new Rhino file, by default, line types and hatches and even annotation styles are left empty. The reason for that is that they are left empty because we don't want to, say, bloat the file size, right, by adding a bunch of custom default line types and hatches that you may never want to use. And so those only really get added if you either open the panel for line types or hatches, or if you go here under tools, and let's say you go to hatches, here you can see as soon as I click on this, it auto-populates this list. Same thing with line types. It auto-populates a list of line types. So you can either, but by default, those are empty. Because I've already loaded those and saved this file, those will already be saved in this document. So when we query these, when we use a query component in Grasshopper, it will find those. But if for some reason you open a Grasshopper file that has a query component and it just is returning nothing, you might want to go and check to see in the hatches or line types or annotations that there is something there, right? And by default, as soon as you click on that panel or as soon as you click on that option, it will automatically preload those. And the next time your Grasshopper solution is expired, it will find those. So next, everybody should launch Grasshopper. And again, hopefully we're all using the same build. I think we should be all using the same build. The reason why you could have used just the Rhino 8 build off of Serengeti, which is pretty close to updated. I think that build was probably updated on Tuesday. But as I said, we're constantly adding changes. And so PK and myself both added some changes earlier this week to fix some bugs. And so that's why I wanted to get you the latest and greatest build. And so here, I'm going to go ahead and open up. Well, you guys don't need to do this. I'm going to show you what the final stage of this is going to be, so that I can show you how it works. The one thing that we know that there is a bug here is that, and we'll talk about it more at the end, but we're baking some blocks, and by default, it puts them on this Grasshopper layer, and this Grasshopper layer has some transparency to it. The bug is that nested blocks do not show up on layers that have a transparency assigned to it. I know it's kind of a weird bug. We know about it and we're going to fix it, but it just hasn't been fixed yet. So the trick is to just change that layer to be fully visible with no transparency. And there you can see now we've got blocks. So what does this definition that we're going to look at and build actually do? Well, it's a parametric grid, right, for column spacing. But it has a lot of interesting things about it. For one, I can easily change the grid spacing. These are all live, by the way. I can select this column if it's not locked. I can select this column and it knows that it is column C1, or this one knows that it's B4, right? So all of these blocks, they're nested blocks, but I can control the spacing. I can even very quickly modify the row and grid count, right? So if I add 7 here, now you can see I've got 7 columns. And so now I can add or remove columns, and the grid is fully parametric. You can see it added 2 new F and G lines to accommodate those. So, and additionally, what's also kind of neat is it's responsive to Rhino changes. If I move this around in Rhino, it's going to update the definition. If I were to change the rotation, the grid also changes there. So there's a lot of stuff that's pretty interesting about this. And again, this is all driven by Grasshopper, but Rhino geometry with attributes. And so it's a pretty neat little definition that I think it has some potential to show a lot of different features that we've now covered. So I am going to close this and start fresh. Actually, before I do that, I'm going to close this. And then revert. Okay, so I'm back into my base column grid. And the first thing I would like each of you to do is open up step 1. So as I mentioned, step 1, I tried to give you guys some pre-canned stuff so that we didn't have to spend time, making a cluster that does the grid lines and things like that. All of that stuff is just standard Grasshopper components that have been around for over a decade. So I didn't really want to spend much time dealing with that. But it does have you can control the spacing with these sliders, and also the extension is sort of the extension from the ends can be controlled. And so what we want to do, excuse me, is we want to bake these lines, which are not in the model, onto a specific layer and also give it a certain name. Okay, you can see I've sort of isolated the baseline grids. Those are the ones moving along the x-axis, and then column grids, which are the ones moving along the y-axis. And so the first thing we want to do is go to the Rhino tab, and again, I'll just make this full screen. Here is the tab with all of these new components, and you can see there's a bunch of them, but we're going to try to cover as much as we can through some of these. But for objects, like geometric objects that you want to assign attributes to, really what you want to be looking at is this particular subcategory. So it's under the Rhino tab and object subcategory. And really the one we're talking about most is this model object. Okay, so under the first section it says model object, we can add that to our canvas. So we have a model object, and you can see that it has a geometry input. You can give it a name, layer, and so on. So we're going to look at some of these things. So the first thing we want to do is assign, we want to tell these baseline lines that you see here, we want to assign some attributes to those lines, right? So the first thing let's do is create a name, a unique name. So these are going to be 1, 2, 3, 4, and these are going to be my vertical lines, and the y-axis are going to be using alphabetical notation. So to give these names, let's use a list length and find the number of lines that we have, right? In this case, 4. And then let's just use a series component, and we'll assign the count and the start value to be 1. Okay, so if I look at in a panel the output of this component, you should see it goes from 1, 2, 3, 4, and that's going to be the name. So like the first line will be 1, 2, 3, and 4, right? So easy enough. So we can just assign that as the name of our lines. And again, now if I look at the object that comes out, we have a model curve, and the name, right, I can look at this, is 1, 2, 3, 4. And so you can see it appends the name of the object if it has one. So it's a model curve and a colon and the name of the object that we just assigned to it. So far, so good? Any questions so far? Everybody with me? I tend to go kind of fast, but that's also because I've used it a lot, and I know you guys haven't. So if I move too fast, I certainly just let me know. I'd like to move as fast as we can because there's a lot to cover in just 2 hours. That said, I don't want to move so fast that I lose each of you. So I want to, make sure we go slow enough, if that's okay. So the next thing we want to do is essentially do the same thing, but this time for the column grid, right? For the vertical lines. And so again, I need to go over here and look at the model object. So pull out a different model object because we're going to assign different attributes to these lines. And this time I'm going to do another list length to find the the number of column grid lines that we have. But instead of assigning a number like we did here, 1, 2, 3, 4, now we want to use a character sequence. So I think it's under the math or sets character sequence or car sequence. So under sets, sequence, car sequence, this is asking for the count. And so we can just pass the list length into the count input. And you can see the output now is A, B, C, D, E. And it's auto enumerated. And the reason why it's auto enumerated is because we have the character pool. The character pool can be anything we want, but by default, it's set to be our alphabet, right? And so it's just going to basically go through and say, create 5 different values, A, B, C, D, E. If we give it a list length of 7, it's going to, take the first 7 in the character pool. So this time, those are going to be the name of our objects. And it turns orange because it says object failed to collect data, right? So it either needs to know the object or what geometry we're talking about. And right now we haven't assigned anything to that. So let's take the column grid lines and assign it the geometry. And now you can see that error goes away. If I copy paste the panel here, you can see now we have model curves A through E, whereas these are 1 through 4. So far, so good. So if we were to bake these, you could right click and say bake. I wouldn't do that right now, but if you were to hit bake, you would literally get 4 lines. If you selected it, it would have a name 1, 2, 3, or 4. So we're partly there, but this time we want to actually assign a layer to these objects, right? We want this geometry to be put on a specific layer that we can control. So first I'm going to sort of move these objects up and these objects down. By the way, if you get lost on any of this stuff, you can always open the subsequent step and it will have done all of the stuff we're covering. So step 2 has all of the stuff that we are going to cover here manually. And so if you get lost or you need some help, you could always sort of skip ahead and open step 2 and just follow along. So that's another thing that you could do. Okay, so we need to create a new layer. And there's a couple different ways we could do that. One is we could simply assign, go ahead.
And we have a question in chat. What is the difference from connecting the lines into object versus geometry?
Good question. So geometry is just the raw geometry without any attributes. Okay. So by default, curves don't really in Grasshopper don't contain any information about what layer it's on, or its print width, or things like that. So we can just pass that into the geometry part of it. However, let's say we were to bring in, let's say we had a sphere and it's on the default layer and has all these attributes, right? If I brought that in as an object, I could then deconstruct it and find out what layer it was on, right? Or what print color it was assigned, and so on and so forth. So object is like sort of the parent, sort of the more robust version of the object, if that makes sense. It's the one that contains all the attributes. Whereas geometry is just the geometry, the underlying geometric type, right? So is it just a line? Is it a circle? Is it a B-rep? And so on and so forth. Does that make sense? It's a good question. Yeah, let's see, I don't have chat pulled up, so okay, yep, thanks, good. All right, so to make a layer, we could just say my layer, right? In the text panel, and if I attach that here, if I were to right click and bake that, it would create a new layer in the layer panel called my layer. But we wouldn't be able to control any of the other attributes of that layer, right? We wouldn't be able to control its line type or its display color or anything like that. So if we want to have more control, so this would just create a default layer with a name, with all the default settings with just a different name. So if I want to have more control, now we can go over to the model tab and you can see there's one called model layer. And it has the same sort of, you see here we have a red, white, and blue layer icon for layers. Same thing over here. Grasshopper one, I'm just trying to keep the same sort of color panel and color coding system in Grasshopper, but essentially it's the same icon. So that helps you understand that we're talking about a Rhino layer here. So here we want to define, let me pull some of this over so that I have a little more space. Now we want to define what layer these objects are going to be assigned to. So let's do a panel. You can either, for those who don't know, you can go to parameter input panel, or you can double click on the canvas and type 2 forward slashes and then start typing whatever you want, and that will be displayed in the panel. So sometimes I shortcut it to be that. So I do 2 forward slashes, and then let's say we want a layer called Anno, and then 2 colons, and this time I want to say grid lines, right? So I wish that we were in person, because I would then quiz you guys as to what do the 2 colons mean. But because I can't really see you and none of you have your cameras on and it's hard to get people to speak up, I'll just explain it. The 2 colons actually mean a sublayer, right? So anytime we define a layer with a name that has a colon, it's going to create a parent layer called Anno, and then a sub layer called grid lines. So you can create as many child layers as you want using this this type of text system. So a double colon lets you define sub layers, if that makes sense. And you'll see how that works when we bake this. So now we have assigned a layer name. Let's then specify a color that we want for this this particular component. So, or for this layer. I like to, I don't know what the default layer color would be, but I would like to make these black because I think it's easier to read black lines on a gray or white background. So I'm just going to go right click on the display color, go to the color input, and drag the color slider to be all black. And now that means if I look at the output here, now that means I have, well, it's not going to show me, model layer Anno grid lines. But if I look at the output, you can see that the display color is going to be set to 000, right? This is kind of nice because it's also giving me the attributes of the layer that I'm talking about, right? So I can double check in our deconstructor, basically the outputs of the attributes to see what our color has been set to. The last thing I want to do is set the line type. Again, we could set all of these using like the model line type component here. Or actually here you would do object line type, the object line type parameter, or object line type component. All of those are viable, but just to keep it simple, I'm going to right click and say set line types. And because these are center lines, and because remember I just said our base file already has those line types loaded, right? This would show up empty if it was a new template. But because I've saved this file and I'd already loaded those line types, this is populated so I can choose center and then deselect it. And so now this layer knows that it has a model line type center, which is referenced to this document. So if I then connect that to this layer, and I'm going to assign this layer to both of these, right? I want both our baseline and our column lines to be assigned to this layer and have those same attributes. Now, as I mentioned, I'm already sort of cluttering up my space, right? So here's a trick. You can right click and say hide unused parameters, or you can hold, I think it's shift, nope, control, double click. So if you hold control and double click on the component, the middle of the component, it will collapse the component to hide all the unused inputs and outputs. If you hold shift and double click, it will do the opposite, right? It will show all of the parameters. So control hides them and shift shows them. Shift double click or control double click. If you forget that little trick, just use the menu, right? They're the exact same thing. You can always do hide unused parameters and it does the exact same thing, but holding shift is a little bit faster, right? All right, so we've now created a layer and assigned it some color, a color and a line type. Let's also set the drafting scale, the line type scale, because what you'll see when we bake this, we want to have control over the density of our center line, right? We have assigned center line, but we now want to control how that is displayed by basically the line type scale. And to do that, that's found under the drafting attributes. And so I can go to the drafting attributes, and you can see drafting, right? So I know that the input for here is looking for something called drafting attributes. And here under model objects, I have something called drafting attributes. You then have other things like print color, print width, which have its own components if you want to control those. The one I'm interested in is the line type, or sorry, the line type scale. So here it's literally a numeric value. And because I've already set up this scene and know the range, I recommend creating a slider. We're going to change it to integers, and let's put the minimum of 100 and the maximum of 1,000. Again, you can do this the way I just did it, or you can set that through double clicking, but it doesn't really matter. On the canvas, you could do something like 100, I think it's 2. Yeah. So you can double click and say 100, 2 dots, and then 1000. And it creates a slider between 100 and 1000. So that's another way. But in this case, let's just put the slider. It doesn't really matter because we haven't baked it. You'll see what happens when we do. But in this case, let's just set it to be somewhere in the middle. I'm going to shift double or control double click again to kind of make that smaller. And then I'm going to assign the drafting attributes to both of the model objects, right? Because again, we want these to be on a certain layer and also have a certain line type scale. All right, we're almost there, at least with this first part. The last step that we need to do is we need to bake this, okay? So that, because right now we're just assigning these attributes, but it's not in our model anywhere, right? We're just looking at Grasshopper geometry at the moment. We want to bake it so that these become objects in a Rhino model that are assigned to a certain layer. So again, under Rhino, you'll see a little fried egg under the content tab. There's something that says bake content. And by default, you can see it just has a content input and the update button. So let's go ahead and connect the object output of our first model object attribute and then holding shift down so that we can add more than one wire into an input, holding shift down and add the bottom one objects into that input, okay? And then hit update. And when you do, you should now see that in the layer panel, we have Anno as the parent layer, grid lines as a sublayer, right? That was all defined by that double colon, right? Also, if I select grid lines, well, actually, I need to pull it out more. You can see the line type has been set to center, right? And so that was defined by those drafting attributes, or actually the layer settings, excuse me, because we set it to be center type here. The last thing I'm going to do is turn the preview off so that we're not seeing the preview of and also turn the preview on our cluster off. Because really what I'm interested in is seeing the center lines in our Rhino model. Now, one thing that we haven't done, remember, we have a slider that's going to control the line type scale, right? If that looks too dense or not dense enough, we want to be able to control that with this slider. However, right now, if we make a change, it doesn't update on the fly because we'd have to hit this update button every time and then it updates. But we want to be able to do this automatically. So what we can do is if we zoom in, you see there's a little plus button underneath content. And that plus button lets us add a new input. Now that button goes away and we have an input called bake, right? And if you hover over it, you'll see that there is a, in the tooltip, it tells you that if you pass in a null, it is nothing. If you pass in a true, it is going to bake the objects. And if you turn false, it essentially unbakes the objects from your document. So it actually removes those things that it just baked from your document. So we want to add a Boolean parameter, or a Boolean toggle, excuse me. I like to just remove this because it's too long. By the way, I highly recommend turning on draw full names under display. If you're not, you won't necessarily see the full name of each of the inputs. And I realize that adds a lot more, makes these components a lot larger. But at the same time, it's very hard. Like if I turn that off, you can see it's just a single letter. And so that stuff becomes much more difficult to understand what I'm doing, right? So I would highly recommend turning display draw full names to be on. And now you can see it's going to show you the full name of each of the inputs and outputs. That's just this preference setting, preference of mine. You don't have to follow it, but I think it really helps in this particular case. Okay, so if I go to true, now you can see, again, we have an Anno layer, we have grid lines, and we can select it. But what I can do now is change that slider and you can see the density of my lines changing on the fly. So every time this slider is moving, it's baking a new object, but it's only updating the one that was already there. It's not necessarily adding a new copy every time. And that the reason for that is because the default setting for this baker, the mode is set to update, right? We don't want to do insert because then we're getting copies of each of these objects every time. We simply want it to update the geometry or the layers and so on. Are there any questions?
We have a question. Is the update mode actually deleting the old Rhino geometry and creating a new, or it's just updating the existing one?
You can think of it like it's essentially updating the existing one. And what I mean by that is it keeps the same GUID. Yes, the GUID is the same. So what I mean is that I think it is actually under the hood. It is creating a new object, but it is copying the GUID from the one it's deleting. I may be mistaken on that, and really the baker is the brainchild of Kike. And so the under the hood part of that, he has a lot more knowledge about. But that said, I'm pretty positive that I mean, you can think of it as essentially the exact same object because it does have the exact same GUID. And you can test that by looking at, we could actually look at, I think I can do GUID, pass the content, and look at the object GUID here for each of the objects. And if these were different objects each time, pull this down here, those would be changing each time, right? But you can see those objects don't end up changing every time the solution. And that's really key, because what we don't want, I mean, we need those to be the exact same so that it is updating the existing object. But great question, Charlie. Any other questions? Do you guys want to have 5 minutes to try to, well, if you don't have any questions, we've got a lot to cover, so I might just keep moving on. But there are any number of other attributes you can set. You can assign material color to an object. You can set display settings and so on and so forth. But really, all we need to know at this point is the stuff that we've talked about. But really, you can dive deep by going to the objects and looking at all these different attribute types. So you can look at the display or the drafting attributes or the render attributes or the visibility attributes. And all of those things, like you can have these be locked, or you can set the layer to be locked, right? If I do shift, you can set locked on a layer. So if you want to bake it to an object or bake an object to a layer, but then lock it so nobody has control over it, those are things you can control right here. Okay. Because there's so much to cover and because we're already an hour in, do we want to keep going or do we want to take a quick break? I'm looking at it. Keep going. I see.
Keep going. Yeah.
All right. Awesome. We'll just hold it if anybody has to use that. All right. So we've now covered essentially creating objects and assigning object attributes to them. And I think that in and of itself is like, if you just walk away with that from this workshop, you're golden, because there's a lot you can do with just that, this particular component. I'm going to now open the step 2, okay? The column grid step 2. And column grid step 2, you can see, is everything we just did. The only difference here that you may have noticed is that instead of this bake, I'm just using, there's a value list here component, which literally just lets you set bake to true, nothing to null, and unbake to false. And so you can actually set it to unbake or nothing or bake. Don't know why I'm getting. There we go. So here I've got the exact same the definition. Whoop. Actually, I want to open step 3, if I'm not mistaken. Yeah. All right, so step 1, or maybe 2, was essentially developing this section, right, which we just talked about. There is one thing I'll talk more about here, which is adding tags, but don't worry about that for right now. Let's just keep what you had with the layer and the drafting attributes and the model object and the baker. So if you should be on step 3. Excuse me. Get some water. And I'm going to disable this component right here so that everything downstream right now won't work. And what this and I'm going to add a new one to our canvas. This is one of the things that I'd like to highlight, which I think is incredibly useful, are these query components. Okay, you may have noticed if I expand the ribbon that there are a bunch of icons that have little magnifying glasses, right? There's a layer query, there's a query model objects, there's query materials, there's query viewports, there's query annotation styles or installed fonts. There's a bunch of different query components up here in this document. And query is essentially a read-only operation, but it's going to retrieve some information about that type from the Rhino document. And the one that's really handy is this one called query model objects. So you can see it has the same cube, the model objects component, but it just has a magnifying glass. And go ahead.
We have a question, actually comment, more like, it would be awesome if the bake content would accept an autofill value list like some other components, like parentheses bake.
I agree with you, Colin. But however, the list is really not very long. It's 3. And honestly, the only 2 you really need are true and false. Null is really not all that useful. It doesn't do anything. So it's basically like this component is not doing anything anyway. So to be honest, you're probably just as used. I mean, you can just use a Boolean toggle to do true or false, and that gives you everything you really need. I think this is sure. I can see that being useful, but again, I think it would be useful for some types, not necessarily this particular type. My own opinion, but it's a good suggestion. But moving back to the query objects, query model objects. If I look at this component, so if I look at the output of this component, you can see the query component is bringing all of the geometry that it can find in our Rhino document. So as I said, the query component's job is to query the Rhino document and return all of the objects. If I look at the layers, the query model layers, this one just gives me those 3 different layers that I've created, right? So if I go back, there's literally 3 layers, one called default, one called Anno, and a sublayer called grid lines. So you can see it's giving me all of those. I can query for line types. So again, because we've got those stored, it will give me geometric or data types. The data type itself is a line type, and it gives me enumerated for hidden, center, border, you name it. So the query components are actually super useful, but it gets even better. We can filter these objects in a certain way, right? So let's say we had 30 different layers and we only wanted the objects on the grid lines, right? We can say this layer is an optional layer name that we want to filter. So we only want the objects that show up on the layer panel. So I can say, I can again do / Anno, 2 colons, grid lines. And hit enter. And now if I had more, and actually just to show that, I'll create like a VREP out here so you guys can see. So that one is going to be on the default layer, right? You can see it down here at the bottom because this also has event listening. So each time an object is added to our canvas, it's smart enough to automatically update. I don't need a trigger. I don't need to hit F5. I don't need to hit solution, expire solution, or recompute. it's listening to changes in the Rhino document and will update accordingly. And so let's say I have 2 model extrusions, 2 of these are on default, the other lines are on this grid lines. I can filter those extrusions out by simply saying, I'm only want to concern myself with the ones that are on the Anno grid lines layer. Okay. Or I could alternatively filter for a name, right? These all have certain names, right? So A, B, C, and D. Let's say I wanted a name, I just wanted the A curve. I can do that, and you can see it gives me the model curve A. I could do the other cool thing, and I don't know, let's see. Unfortunately, these don't have different names. Is this has a really interesting thing that has what's called a match method. And so this is actually testing using, this is a special parameter that lets you set how you want to search this filter. So you can use regular expressions. You can say contains, starts with, ends with, equals. So wildcards by default is what we're using. But so if you had something like, if let's just say I wanted to call this line, let me give this a name, ABC, right? And this one is just AB, right? So I've got one curve called A, one extrusion called ABC, and one extrusion called AB. So using the wildcard, I could do under the name, because that's what I named. I have, this is trying to match any curve that is A. But if I do A asterisk, it's going to give me anything that has A and then followed by anything else, right? Or I could do AB asterisk. So now it's going to only give me the ones that have AB, but it took out the curve, right? The other way I can do is negate that. So you can set the match method or negate. So here, instead of doing wildcards, I might want to do starts with, right? But in this case, it doesn't know what an asterisk is, right? So I can just say that, and I'm back to our setup. You can see each match method has a different little icon. So this is starts with. You can see match method ends with is the opposite. You can see contains, regular expression. They all have like different little icons. So that's what those little icons mean. But let's say I have start with, and let's say because I'm doing starts with AB, it's giving me anything that has a name that says AB. In this case, let's say I want to negate that. Now it does the opposite. It gives me all of the items in the Rhino document that don't start with AB, right? So that's acting as the inverse. And now you can see it has a negate and a start match method, right? So this is really fun to work with, I think, especially depending on how you're starting to work with your data. In this case, I'm going to just, again, if I wanted to do A star, I moved it back to the wildcards. You can see it gives me everything that starts with A. Now, in this case, like I said, what I'm really interested in is the stuff that's on Anno grid lines. So everybody should create a text panel and assign that to the layer called Anno grid lines, because all we really want to be returned are the curves that we created on this layer. So this is essentially letting me control that. Actually, before I do that, I'm going to go back and just take this out. Now,
we have another question actually. So actually one question. Gerald says that he often uses custom C++, C# components for those matching filters currently. So it's a nice feature. And Aman says, what's the difference between query model object versus geometry pipeline? Does it provide features which don't align with geometry pipeline, or it's a completely different feature?
Awesome question, man. You guys are sharp. It's almost identical, but I think this is a little bit more full featured, and I'll show you why. So you're right. The geometry pipeline is here, and it lets you bring in stuff with layer or a name or a specific type, but it really only gives you certain types that you can control, right? So you really only have these 4 different types. You can include this, and so on and so forth. It doesn't let you do this. So again, one thing this doesn't let you do is have really control over the matching method. So if you had a layer, and the reason why we added this feature was, let's say I had a layer like this. Okay, so it's a bracket, and then it has a literal bracket, ABC, and another bracket. I can't search for that because if I use the wildcard expression, it means that bracket means something in the wildcard. If I wanted to like literally extract that layer or get the objects on that layer, I, could type it in like that. And if I put that in here, the same thing if you were to type that in here, you wouldn't get any objects, right? And the reason because it's using the wildcard matching to match for layer here. But because of this, what I can do is set it to equals. And now if this was on that layer, it's actually going to give me the object on that. So it's going to, so the one thing is that you have greater, finer control over filtering. Jaffe made a good point in that this is returning objects as opposed to just geometry. Objects meaning it's returning model extrusion, and if I were to deconstruct that, right, let's go to our model object and let's deconstruct that. I can get that it's on this layer, right? It's on model layer brackets, or it has a display color. Let's probably have to deconstruct it more. And display color. By the way, regardless, you can kind of continue to deconstruct it, but it is retaining all of model objects as opposed to this, which is just returning the geometry. The last thing I want to show is you can right click and say show all parameters. And when I do that, you'll notice it adds a whole bunch of outputs. And what that does is I'm going to go back and actually take this out and change this back to wildcards, so that the objects output are essentially everything, right? Because I don't have a filter right at the moment. So that would be like this. But if I show all parameters, I can break it out by type. So in this case, if I just wanted those extrusions, I can filter by type, right? Or if I just wanted curves, I could just do the model curves, right? So these outputs are kind of key in that it lets you, this only spits out, just a list of the objects, especially if you have everything. In this case, you can actually also filter by type by using a specific output, if that makes sense. So I think it's a little bit more full featured, but that's not to say it's not good, in and of itself. But it is very similar to the geometry pipeline. All right, so I think I've covered query objects and how they work. And like I said, it doesn't just have to be query model objects. It could be layers, it could be line types, annotation styles, whatever. So I'm going to delete these because I was just doing it and go back up to our model or up here and re-enable that. Because now what you see is I am returning the model curves for anything that's on this particular layer, right? And I'll just get rid of that layer because it was just an extra one. So we have the curves that we want to address, and the next thing we want to do is we're going to create, and we created again. I created a little cluster because so that we don't have to necessarily do that. What we want to do is we have the start and end points, basically these down here, as well as bubbles, which are the circles at either end. Okay. Really, the goal of the second stage is to show you how to create some annotations. And what I mean by annotations is the text entity. So we're going to assign the labels for these bubbles. Okay. So the first thing we want to do is we are going, and if I look at these, there's a new component up here that I've connected to the object's output. This is found here. It says content information. And one thing that's kind of useful here is it's a very quick way to get the names of our objects, right? In this case, remember we assigned 1 through 4 and A through E. That's an easy way to do it. Now we could have also used the model object and used the name here, right? So it's kind of the same. They're giving me similar information. But in this case, I'm getting the name from our content that we created. Okay, so we've got model, we're taking content, which is our model objects, and we have our names. And that's the label that we want to assign to each of our objects. And so what we want to do is go to our annotations now, and you'll see here are all of our annotations. We can add align dimensions, angle dimensions, leaders, linear dimensions, radial dimensions, you name it. Everything down here, which we'll talk about in a second, are dealing with annotation styles. So if you don't know much about annotation styles, you can edit those. If you open the document, go up here to annotations, and we're currently in annotation styles. We have 5 different annotation styles in this document, but you can go into here and hit edit. And these are all the different stuff you can do, right? You can change the font, you can change the text alignment, you can change the dimension, like how dimensions work. So basically, we have annotation styles that we can query, right? If I query annotation styles, like I just talked about, it's going to return all of those 5 different annotation styles. You could then deconstruct those using you don't have to do any of this, by the way, I'm just showing you, using the annotation style component. Right, so I pass that in, and you can see, well, I have lists now, but essentially you can get access to all of those settings that we just talked about up here. So if I go to feet decimal, edit, and I want to control everything about like the arrow size or the font height or the text gap, all of those are settings that can be controlled through here, through these settings. And so you can see there's basically one giant one called annotation style, and then we have one called text settings. And text settings is essentially the equivalent of the stuff that's found under the font and text settings, right? So we have font and text. So all of these things like font, text height, text gap, all the things you find under there are found under the text settings. We have one called dimension settings, and that lets you control all of these settings. So all of those can be controlled through these different things down here. You see, we have annotation dimension settings or annotation text settings. Those are the things that we can pass into here and set each of those individual attributes. So going back, I've already actually created something, and actually let's hold shift and double click because I want to show a couple things, and I'm going to get rid of this stuff. So here in your file, in the file that you should have opened, we have one thing that is our model font. This is letting us control what font we want to use. So if you right click on it and say set fonts, it takes a minute because it's indexing your entire font catalog on your computer. But we can go to set font and we can control if we want it to be Arial or Barlow or Bauhaus or whatever font you want. You can control that through here. You can even control the font weight. If you want, right click and say font weight, you want it to be bold or heavy. You can control the font style if you want it to be italic or oblique. All of those things you can control through this model font component, right? That's all set here. Then we have text settings. Again, under annotation text settings. And this is where I was showing you have the font, the text height, the text gap, mask color, horizontal alignment, all of those different settings. So what I'm doing is I'm passing in the font that I want to use. I'm also going to set a value for the text height. The text height is depending on the bubble size because I don't want the text to be larger than the bubble, right? So I'm essentially using this min component to limit so that the label never goes outside the circle. Okay, so this is all just simple Grasshopper stuff. But I don't want to see all these other, the only thing I'm really interested in is the font and the text height. I don't really care about all this other stuff. So again, I'm going to hold Control and double click and minimize that so it's a little bit smaller. All right, so the next thing we need to do is create a text entity at the center point of each bubble. So we go to Rhino Annotations and Text Entity, okay? And what we need to do is, let's just say we can start with the start point. The plane is going to be at the start point. So it's going to create a new text entity at each start point. And by default, it's just giving us an ABC value. What we want to do is give it the name of that item. So we have 9 points and we're passing in 9 values, right? And because we've done that, I'm going to hide this so that because we've done that, you can see now we get A, B, C, D, E, and 1, 2, 3, 4, which is exactly what we want. But it's only on the start points, right? We need some at the top and the other end. To do that, we just need to make another text entity and assign it the endpoints. So I'll just do another text entity. And the endpoints are going to be the plane, and the text is going to be the name. Now, I want to have control over the size of that text, right? Because right now we have bubble size, right? But the actual text is not updating, right? We want to be able to use this font size. Well, to do that, remember, all of these components have things sometimes hidden because we didn't want just to have these things super long on all of them. So if I show all parameters, I get one additional input that says text settings. And I want to use the text settings I just created, which is the font that I want to use, in this case, Arial, and the text height. So if I pass that in, now you can see the font, the letter changed a little bit. I'm going to do the same thing, show all parameters, and pass the text settings into here. Right? So now when I change this slider, I can control the text height of those letters. Now you'll notice that it clamps it so that, like, if I make my bubble a little smaller, you can see that even though I'm trying to make this font bigger, it's not letting me because I've done this minimum calculation. All right, it's you taking the minimum of the bubble size or the font size and using that as the text height. Okay, I see the comment here that it should expose all possible settings. I mean, I get it, I get that, but you'll see, like, on some components, particularly under annotations, that can just be unwieldy. That's not to say they're not useful, and we've tried to expose like as much as we can, but you can see, like, linear dimension. If I show all, which would you rather see? This or this? When you may not even be interested in all of these different settings, right? You may not be interested in arrow or units. You just want to use whatever the default annotation style is, which is what this one will do. And so we had to make a decision whether we wanted to show all or kind of hide some by default. And so this was our solution for some of these. But going back, so we're almost there. The last thing we need to do is we're going to do the same thing we just did earlier, which was to assign these bubbles to a different layer. All right, so we have our grid lines and our grid lines. Let's say we wanted to make these bubbles to be on something called Anno bubbles, right? So again, we're just going to go to our geometry objects and our model object, and we're gonna, the geometry or the objects that we want to, or the geometry we want to assign is the text entity. So I can hold shift down for both of these because I want them both to go on this layer. And I can add a new model layer component and assign a name called Anno Bubbles. So again, using the double colon scenario, I can give it a name. And the other thing I want to do is, just like before, I want to set the display color to be black. Because again, I want to be able to control the color of what these bubbles look like. So again, holding shift, I can minify that and add that to the layer. I can then, and then the last part is we want to bake that content. So I'm going to go to Rhino and add another bake component, and we want to bake the objects, right? The objects are what we're concerned about because we've just assigned an attribute like the layer, right? And so last thing I'll do is add the plus button so that this automatically bakes every time I do this. And there we go. The one thing I have forgotten is that I also want to bake the bubbles. So the last thing I want to do, the bubbles are just the circles, right? It's just a cluster that's giving me the circles. So I'm going to hold shift down and add that to the geometry output or input. So I'm assigning this layer to the text entities, but also the circles. And then I'm going to turn the preview off. And now you can see, because I've assigned the baker to be automatic, that our bubbles are in our scene, and now we have you know, a fully parametric grid line. So you can go back and modify these sliders and see them update in real time. Now the nice thing is, because I'm using this query component here, instead of just, you know, I created the model curves here, right? I could technically just take these directly over here and do the grid lines and so on and so forth. But because I use the query component, if I make a change in Rhino, right, it first is coming here, it's creating the baked object, it bakes it. But if I move that object, that move is going to then update in the query component because it's listening to changes made in the Rhino document. So if I now move it, you can see that grid line updates because it's not recalculating this part because that stuff's already done. But because this component, the query object, is smart enough to have event listening turned on, it is listening for changes in the Rhino document. So when I make a change there, everything else is then updating, which is essentially the bubbles and the location and the name and so forth. Does that make sense? So that's a nice feature of using the query component after the bake, because the query component. Now, if I hit, so let's say I made a move, right? And now I hit solution expire, it's going to go and expire everything. So it's going to kind of reset everything back to its original grid position. So, you know, that change is temporary. But it is kind of neat to see changes in the Rhino model update from the Grasshopper back and forth. The last thing I wanted to show real quick is the preview, the custom line preview. So if you go to display, this is what I was talking about, that it's been kind of annoying to create drawings in Grasshopper / Rhino because you've had very limited control over the way lines look and feel in a Grasshopper preview setting, right? Because up until Rhino 8, we only had the custom preview, and that really just allowed us to have shaders applied to 3D geometry, not curves. It would give you the color, but not the line weight, and so on and so forth. So we have this new component in Rhino 8 called Custom Curve Preview. And it is asking, what is the curves that you want to draw? And then what is the line type you want to use? And then, of course, the color. So, for example, let's say we wanted to change, in this case, I really am interested in the bubbles, but I'll also show, like, if we wanted to make a change here. Let's say I wanted to, let's say, in this case, I just wanted to show off the taper thing that I was talking about, right? So in this case, I can say the curves are the grid lines, right? These are all my model curves. These are these guys, right? Coming in through the query component. So if I pass those in to the curve input, now it's just asking me for the line type that I want to use. So I go back here and I can either use a query model in a list item, or I can use the model line type and go up here and say right click and set line types, and let's say center, right? So now the default is the center line type that I've just created. But let's say I want to change like the width and the width units. And again, here you have some hidden things, because by default, the width unit just lets you, here, let's just add a slider here. And I'll just change the size of the slider. So if I say width, and then use this model line type. I should be able to see, yeah, there we go. So you can see now I can make them thicker, right? It's still using the same center line type, but I can make the overall size. How does a query function work in real time when we work with 5,000 to 6,000 model objects, like a tower facade or something? It will slow down, but I would also recommend trying to pre-filter this stuff here, right? So if you're only concerned with 10 floors out of your 6,000 model objects, if you pre-filter, it's only then going to give you 10 objects that you can then work with, right? So it tries to be smart about how to deal with it. If you find it's too slow and you want to manually update it, one thing I forgot to show is you can uncheck this update automatically. When you turn that off, it will show an update button here, and that will let you manually update when you want, right? So this will query the object for the filters you want, but it will only update the stuff once you hit the button. So if you don't like the automatic updates, and because it's slowing things down and stuff like that, you can choose to turn that off and just do a manual control. Update is more like a data dam, correct? So yeah. All right, so going back here, we have width. So we've set the width of these lines. You can also set the width unit. So now we have a new data type called unit system. So you can use pixels or millimeters. So now it's trying to draw the line in 6 millimeters. Or we could change the width unit to document units, which is feet, right? In this case. So now it's trying to make each grid line 6 feet wide. So this is kind of unique in that, so 6 feet will, as I zoom in, you see these get bigger. If I do 6 pixels, it's going to try to stay 6 pixels regardless of the zoom scale, right? So that's also kind of useful, is that it's 6 pixels if I zoom out here, or 6 pixels if I zoom out here. If I use actual model units, it'll be 6 feet. So if I zoom in, the line gets wider. If I zoom out, it gets smaller. The other thing is, if I do show all parameters, there's 2 more which say taper width and taper position. Now, if this is unconnected, it will just use this slider by default. But if I connect something here to taper positions and then make a copy, whatever I assign here will override whatever I've assigned here, if that makes sense. So if I have anything in the taper position or taper widths, it will assume that it won't use anything in the width position. But essentially what this is trying to do is let you control the taper of your object, right? So if you wanted to have some lines that are thicker in the middle or thinner in the middle and thicker on the outside, so on and so forth, you can do that. And so it's got some kind of neat, interesting things you can do. There's still some things we want to enhance, probably in Rhino 9, maybe even allowing for multiple taper positions and stuff like that. But at the moment, you can really just control a single taper position and single taper width. So what I'm really interested in for this particular example is not the grid lines, but the bubble lines. So here I'm going to change the curve to be the bubbles, and I'm going to check the model line type to be continuous. And now I can control essentially the thickness of our bubble outlines, right? So you can see that I'm controlling that, and I can still control the font size as well, right? So if I move this slider, I can control the font size. I can control the thickness of the bubble size. So there's a lot of variability, a lot of interesting things I can do here to make our drawings look really pop, if you will. Any questions about any of that? You guys have been really good on the questions. Obviously, you're not beginners, which is good. Everybody following along so far?
Yep, all good.
We've already covered a lot. Go ahead. All good, sounds like. All right. Let's jump.
Someone
Go ahead.
asking something, but Okay, we have one question in the chat. The line seems to be not in an active plane. Can you set it?
What do you mean the line is not in an active plane? Which line? These lines? This line is just coming from this cluster. And this cluster is just creating it in the XY axis, I think. It uses a base point, a base plane. So you can actually control where the start is. So this is using the origin point here. So but if you wanted this to be somewhere else, you could set the origin over here, right? And now everything moves over there.
Oh, no, I actually meant when the line is very thick, it's looked as if it's rotated. It wasn't sitting in the XY plane, but it was rotated somehow in space.
Correct. It's sort of like a
degrees.
three-dimensional. You're correct in that. In that it has, it's almost like it's a revolve. It has thickness in all of the directions that you look at it, and that is just a function of. I don't know what to tell you about that. It is going to show up thick in all of the viewports that you're looking at.
Oh, I see. Yes, so it was probably rotated towards our view, right? That's why it appeared at 45 degrees.
Yes, and the taper looks like, so if you had a curvy line that you applied a taper to, like if you had something, something like that, it almost looks like a snake, right? Because it looks like a tube, right? It's like a three-dimensional thickness, if you will. It's almost like it's revolving all the way around. I don't know if I have time to really pull that together, but it does look like it's a three-dimensional tube doing that taper position. So it's not just flat. If you look at it in 3 dimensions, it does look like it's a bit like a three-dimensional taper.
Yep, now I understand.
Okay. Good question. All right, so I'm now going to open step 4 and go back into perspective mode.
I have a question.
Okay.
So when we change any geometry within Rhino, does it also, like the gene pools that we had in the beginning of some number slider, when it retrieves information from Rhino, does it also update those values when they're moved in Grasshopper?
Depends on where you use it, right? Because no, not here, because here we're just using parameters that which is creating the grid lines, right? But then we bake it, so now it's part of the Rhino model. But then we use a query component. So the query component is smart enough to make changes because of this update automatically. It's smart enough to make changes or update itself when changes are made to the Rhino document, right? And this works for model layers. If you make a change, if this is query model layers and you change a color, it's going to update. But essentially, because we're doing this, and then everything is downstream from here. So everything downstream from here, if I make a change in Rhino, will get updated. Does that make sense?
Yes, it does. I was just thinking the feature that you have in human UI, like when you make changes there and you are just listener, there's some listeners there, like that feature is not exactly for the parameters as such.
Right. So everything upstream from this won't be updated according to this change because it's upstream, but downstream, because this is listening to changes in the document, will get updated. Hopefully that makes sense. Okay, well, update and just stop me if it doesn't make sense. Okay, so we should be all together at this stage, and we should have now a parametric grid that has bubbles A, B, C, D, and 1, 2, 3, 4. The next stage is we want to create the points of intersections. Okay, we want to know that this is going to be B2 and this is C4, right, at that point. So to do that, and here you can see this is where we're starting to get kind of interesting because we're doing another query component and it's bringing in everything that we just baked. So not only the grid lines, but now also the text entities and the bubble circles and so on and so forth. All of those are now being brought in. And I could, if I wanted to, do the thing we did before, which was to bake only the things with or filter for just the Anno grid lines layer. But I want to show a different way to retrieve that information. And so we want to look at filtering. Under Rhino, there are a bunch of new things. There's this filter content, there's group content, and then all of these different filters through here. So the one we're interested in is we want to take this list that contains text entities and curves and circles, and we're really only interested in ones that are tagged in a certain way, okay? And we could go through, and so this is where I was talking about this one extra little step that I added. We could add user text here, but I don't really want to necessarily, not that it's complicated, it's just this one's a little bit easier. You can add tags to almost anything, okay? So using, remember how I said the name, you can take content back here and you can get the name, right? In this case, this is the baseline grids, and so it's 1, 2, 3, and 4. Well, I can also, again, holding Shift, I can have this thing called tags. And tags are really almost identical to user text. Well, not almost identical. They're just like adding a label. So instead of user text, which is like a key value pair, right? So if I go to my object, I go to user text, it's literally a key and a value. Tags is even dumber than that. It's just a label. Okay, but you can assign a tag to anything. You could tag a layer. You could tag a line type. You could tag anything. Unfortunately, at least in Rhino 8, the only thing that I know that exposes, let me see, let's just create a plaster layer. The only thing, come on. Excuse me. Now I'm struggling to find materials are the only thing that let you actually tag something. I don't know why I'm not able to find it. Might be. Oh well, it's not really that important because it's not something that is often used. But I would like to go to the hamburger menu. Yeah, like you guys. There we go. Thank you, Jeffy. So under the material editor, this is the only place I know of that you can actually tag things. So you can go to material and add tags. You can click add a new one or remove an existing tag. But to be honest, any data type in Rhino already has support for tags. It's just that we haven't exposed it in Rhino, but we now have exposed it in Grasshopper. So you can theoretically tag anything you want. Same thing with user text. Any, like a layer can have user text, even though you can't really access the user text of a layer. It does support it. So that is something you might want to consider. But in this case, all I want to do is take these lines and add a tag. And so I want to call these, make these have a tag called baseline grid or baseline, whatever you want. And this same thing are called column grid. So these all have a tag. Again, I don't think you can actually look at it anywhere, but this has a tag assigned to it when I baked it, right? Because now instead of baking the object, I'm baking the content. I'm baking the content, right? So now these have been assigned column grid and baseline grid, right? And I want to filter for those tags, right? So everything else doesn't have that tag. Like this circle doesn't have a tag. This text entity doesn't have a tag. So what I want to do is go to my filter and go to filter content. And I want to take all of these objects and I want to create a filter rule, which will tell it to filter the content for a specific rule. And the filter rules are all of these things, right? So you could have a user text that says, you know, the area of a floor plate, and you want to filter for only floor plates that are bigger than 2,000 square feet. Or you could do a rule that says greater than 2,000 square feet, but less than 2,500 square feet. And you can combine those with and filter. So we want to say it has to be greater than 2,000 and less than, and use this filter, right? So you can actually combine these rules in really complex ways. But what I'm interested in is just filtering these objects and looking for that tag. So I want to use, in this case, it could be a match text filter or a contains or equality. Either one of those will, any of these will work. But for simplicity's sake, let's just use a contains component. And in this case, you need to assign two different things. One is the key that you want to search for, and one is the text that you're actually searching. So the key is like, remember I said you could actually look at any object type. So if we had these objects, right? And so I would go, instead of, I would go to model object. Let's say I wanted to look for layer name. I could filter all the objects by layer name that contains a certain thing. Or I could right click on this and search for a material, right? So a material name. So anything that, so you could filter all the objects that contain a certain material. Or any of those things, right? So you can filter by any attribute that you want here by looking at different data types. So here I have model object because that's what I'm filtering. But if you had a layer, if you had a series of layers and you wanted to filter by layers that only were red, you could go here and go to display color and then assign the text color, and it would filter all the layers for that particular thing. What I want to do is go to, or user text, same thing. But we haven't assigned any user text. But what we have done is assigned a tag. So if I go to common properties, any object, you can, common properties are properties that are available for any object in Rhino. So it has an ID, a name, tags, and tags is the one I want, right? Because I want to look at all of our objects and only filter for the ones that have contain a tag for something. So I right click, I go to common properties and set it to tag. Then we can create the filter rule. So I want to say baseline, right? So anything that has, anything that has a tag called that contains the word baseline will now be filtered. And remember, so I don't even have to be all that specific. I could say contains the letter B. So if I had stuff that also contained a letter B, then it would pull those up. But in this case, so I'm not even filtering for baseline grid. I'm just looking for anything that contains the word baseline. And I pass that into the filter. And now if I look at the output, it's taken that giant list and it's only giving me the baseline curves, right? So we've created a filter to filter out all the objects that we're interested in. And this is really useful. I don't know if I'm showing it off that well in this particular example, but using this with user text and creating complex filtering rules and then filtering, you can get some really interesting data flow, data management, right? So again, you can assign floor area and filter for ones that are within a certain area, but also color red and use a certain material. All of those can be filtered through complex rules. Once those keys are chosen, can it be visually externalized on the canvas as well? I would really name those kinds of things. Yes, actually, you can. You could actually just say, I think it works just like this, tags, and it's going to do the same thing. Now, if you do, so now it's using tags as the thing. So you can name this whatever, like whatever the name is. You do have to do, if you do, let's say like model object name, right? You would have to do something like, I think it's object name, something like that. I have to double check that, but you could pass that in. Yeah. or it might be just object period name. I'll have to double check that, but I think you can pass it in a certain text, and it works the same way, because this is technically just using a string. Jaffe is saying right click and say extract parameter. Yeah, but this is still gonna be all that's doing is just saying, is that what you're talking about? This or this?
Yeah, it's more the panel actually, but I guess now you could do the reverse again and put the parameter output to the panel and then internalize it in the panel, I guess, right?
Yes, that's
But yeah, no, it's really the case of setting these definitions up and then sharing them with colleagues, or even like myself 2 weeks later, like coming back at a definition and
so
what the heck did we do?
Like, let's say we wanted to extract that parameter. I thought it was layered display color. It looks like it would just be searching for display color, because it's actually then going to look at what type of content you have, right? So if you're passing layers in, it will look for that. If you're passing objects in, it will look for display color on that object. But I thought for some reason we had to do it, but actually it looks like it's just the raw name.
Sure.
But yeah, the one we're looking for here is tags. But yes, you can just type tags as a text and feed that in. Any other questions? That one probably would be a good auto populate. And we do have let me see if I do have a very thorough guide. Let's see if I can figure out where this guy lives. We're still working on documentation for Rhino 8, but one of them that I've actually already completed is this one on grouping and filtering. So here's if you look that in the link, put that in the chat. But this is a more in-depth look at how to create groupings or filtering and so on and so forth. So if you want to look more into that, I would recommend starting there. All right, so we filter for baseline. Let's create a second filter. Sorry, let me go back over here. Create another filter, and I'm going to actually just copy this. And this time we want to search for anything that has column in it. And I believe now the output of that. Yep. So again, because we've tagged it, and with that tag, we can easily filter out all of our geometry based on those tags. So now we have another way. Again, you could have done it through here, but let's say you had stuff on all different layers and stuff like that with user text or tags, you can also do it this way. Combining baking and query filter feels very useful, even as in this example, you could just take the grid lines from Grasshopper component. Could you give the query filter, other examples of the query filter and baking? I'm not sure.
I just meant if this seems to be part of an architectural workflow, or that's an example of how it can be used.
Both. I mean, I use the query objects component all the time, and learning how to filter and be facile in how you tag things. But like being able to just get all of the geometry from Rhino into a Grasshopper model and do stuff to it, I think is incredibly useful. And then either knowing how this works, so you could either filter by layer or by name, or actually, outputting the types. If you wanted to filter by type, right? That's basically what this is doing. So if you wanted to filter by type, it's essentially giving you all of the curve objects, or all of the annotations are on this one, right? So just knowing how to do any of this stuff is really the key to this workshop, is learning the different workflows of how to get access to the data in your Rhino model, do something with it, augment it, and then bake it back. Is really, I think, the key to everything we're talking about. And that, I think, is useful for this example. but really in your day-to-day workflow. And this is an architectural example that I think could be useful. But I also think any of this in general is useful, if that makes sense.
Yeah, but would you see a case where you would, let's say, bake and keep it on update, but then at the same time go to Rhino directly and move these objects around, for example, or modify them, and then the query would pick them up again?
You could, but then if your baker is set to auto bake, every time you hit recompute, that's any change you made in Rhino is going to get overridden. So for example, if I move this works, right? So everything downstream is working, but that's only because I haven't triggered a full recompute. The full recompute is going to go upstream and say, okay, these are the sliders that have these spacings, and that's going to be assigned to this particular ID. So when I hit recompute, that's going to snap back, right? So it loses all of that change. Does that make sense?
Yes.
So what you could do is not do the auto bake and to get that off, you could actually just remove that input item and you're back to manual mode. And so now any change I do, will update. And if I hit solution recompute, it doesn't modify, right? It kept it there because I didn't update it manually here. Does that make sense?
Yes, it does. That's what this button is actually about, right?
Exactly.
Keeping the.
And if I hit update, now it goes back. So it's a bit like somebody asked about the data dam. It's a bit like the data dam. It's a way to let you either manually control when you're baking or not. And it could be all the time if it's set to true, or it could be this manual update. So that's a great point to make. Okay, so the next thing we now have our filtered content. The next thing we need to do is find the intersections of these curves. So I'm going to go to intersect, and I think it is the curve, and I'm going to take the filtered, the 1 through 4, and also intersect it with the A through E. The one thing I need to do is, so that only gives me 5 points, and so you can see it's only taking the first line in the first curve. I need to graft this one, and now I get all of the points, right? Because it's essentially going on each curve, in this case 1, and finding the intersection of all of these, and then it's taking the next curve and finding the intersection along that one. So now I've got my points, and I didn't really, just because, again, it's just standard Grasshopper stuff, I'm just using a cross-reference. I'm using the names that we used before, right? These names that we created, 1 through 4 and A through E, and using a cross-reference and then joining those so that we end up getting something like A1, B1, C1. And now we have my points. So if we wanted to, we could use another annotation style, in this case, a text dot. And a text dot is just a little annotation type. I don't know if you've used it or not. It's asking for the location, and you can see it automatically puts A's, but the primary text I want to use here. So now you can see by using this text dot, you can see that our intersections are labeled appropriately. So this one knows it's D4, this one knows it's C3, this one knows it's B2, and so on and so forth. And so now that we have that created correctly, our last step that we're going to do is to create some blocks that go here. But are there any questions before we go to the next step? Because that's basically the goal of this step, was to talk about filtering and how you can create filtering rules and combine them, and then using that to create some of these labels. Any questions? What do you guys think so far? These tools useful yet?
Yeah.
I agree. I think it's been. I think once you learn how these tools work, they can be incredibly powerful. All right, so the last step we're going to do is look at step 5. So I'm going to open up step 5. And there we go. All right, so I'm back at step 5, and I'm going to turn the preview on this last little bit. So again, everything we did in the last step is covered right here, right? We just talked about the filtering and making the text dots, right? So we should be right here, but the reason why I opened step 5 is that there's this cluster, and this cluster is there to essentially create a column, right? And it creates a base plate and a column. And they're both made at the origin point. And you can see right now that this base plate starts at 0 and the plate starts, so there's an intersection here, but we'll fix that when we talk about blocks and why it is the way it is. But just to show you like what this does, so I can control the whole offset. The whole offset is essentially the distance from the center. I can control the whole radius, right? If I want to make these bigger or smaller. I can control the edge offset. So that's essentially the outer offset from the holes. And so it's trying to be smart enough to know that I can't go too small. Well, actually 0 would take it as small as I can, but it can't go too small so that it intersects with this hole. And then obviously the plate height is also something variable. We also have column size. And again, this column size is trying to be smart in that it knows it can't get too big because it's related to this whole offset. So if I make this smaller, it knows that it's actually going to change the column size so that we don't have this like weird condition where the column is extending it over into the circles. So you know, there's all things you can play with here. It's nothing all that fancy. You can go into this and look at how I did it, and there might be better ways to do it than what I did. But this lets you actually start to look at, you know, this at least saves us some time from having to build this the geometry itself. And what we want to do is create a column, a block, for example, that goes to each of those annotation positions that we just made. Okay, so I'm going to turn those off. And the first thing we need to do is define a block definition. So if you haven't done it yet, I might recommend going to Show Panels and turn on the Block Definitions panel. And that gives you this panel right here. And you can see by default, we don't have any block definitions in our document. And as well, we have a query model block definitions, right? So this will be empty at the moment, but if you wanted to, you could query for block definitions and filter out only block definitions that have a certain name, or so on and so forth. So we have a block definitions panel open, and we want to make a block for our base plate and for our column. Here's where reason why I created these at the origin. The block. So when you make let's say, let me see if I can explain this. If I make this over here and create a block out of it by typing the word block, and let's say I wanted this as my insertion point. Here it's saying this is the name of my block, but it's also creating an instance. You can see over here that we have one instance, one top level instance. We have our object underneath, but you can see the actual origin of the definition is here. But because the instance, so really the definition itself is actually like it was created at the origin point, and then when we made the instance, it moved it to this position, if that makes sense. And so that's really what we want to do here is we want, because generally you can make, you know, your geometry over here, but it's going to use the origin as the origin of your block definition, if that makes sense. And so that's why I made both of these start at the origin point at 0, 0. So there is a conflict here, but we'll fix that when we make the instances. So the first thing I need to do is go to Object Model and we want to make a block definition. Now you'll notice that there's a couple things that I'm probably not going to have time to cover, but there's an export model block definition, which essentially lets you save geometry out as a 3D file. So you can click here and you can take your block definition, whatever it is. In this case, it's the, you have to first make the block definition, but once you have a block definition, you could give it a file path and whether or not you want to overwrite an existing file, and you hit export, and it essentially takes that geometry and saves it out as a 3D file. And we also have the reverse of that as an import model block definition, where it's going to take whatever geometry you have and import that and essentially bring that in as a block definition. And you can even control the update type, whether you want it to be embedded or linked and embedded or just linked, and give it a name. By default, it will use the file path name, the file name, but you can override that by giving it an input here. So those are kind of useful if you have separate files that you want to bring in as a block into your definition. Here, we're just going to try to make a block definition directly from the geometry we created. So let's start with the base plate, and those are the objects we want to use. And you can see that I get this new type of message box bubble that's not orange and it's not red. You can see it says assign a text to name input in order to create a new block definition. So right now, this isn't technically valid because it doesn't have a name input. It's not a warning because it's not like broken, but it does need a name. So in this case, we'll just give it a name called base plate. Okay. And now I've created, if I look at the output of our pass-through component, you can see I have a model block definition called base plate. If I were to right click and bake this and just hit OK, you can see now I have in my block definitions a thing called base plate. And then I have, an extrusion on layer extrusions called base plate. Excuse me. I don't want to do that. I'm just going to delete that for now because we're going to continue on with this. But we've now created a block definition for our actual block, but we don't have any instances of it, right? We need to say, take this geometry and place it at this point, this point, this point, all over the place. So those are instances, right? It's going to take this geometry, these objects, with this name and assign it to a position in space and create an instance. So to do that, we're going to go to model block instance. Okay. And this is just saying, what is the block definition you want to use, right? So that's the block definition we want to use. And then what is the transform? Transform is just it could be a point or it could be a plane. It doesn't really matter. If you give a point, it's going to create an XY plane at that point. But you could give it a plane or a point, essentially, is all that means. And we already created all of those points back here, right? When we did this curve intersection. So we want to take those points, and I'll just put those into a point parameter. Let me turn this back off and bring this over here. And we want to give the transform points for the block instance. And now you can see we have a, how many? We have 20 instances of something called base plate. So again, we haven't baked anything. So that's why it's not showing up in our Rhino panel. But we do have essentially 20 copies of that one block definition created in our scene. So we want to do the same thing as before. I'm just checking something out. Oh, I'm actually doing this a little bit incorrectly. Sorry. Let me go back. Apologize. So you could do it that way, but we want to make a nested block. So we're actually going to make a nested block. And the way we're going to do that is we make a definition and then we have to make an instance of that object. We need to make another definition for the column. Okay. So I'm going to go back and do the same thing that I did here. In this case, I'm going to go to model block definition. This time I'm going to use the column as our objects. And this time I'm going to give it a name called column. Okay. So we've now created two definitions. I've created one instance of this block base plate, and you can see the transform is empty. So it's basically creating it at the origin, or using whatever, yeah, the origin for this instance. For this instance of the column, I want it to be at the origin, but this time I want the instance to be raised up to the level of the top of the base plate, right? So the origin of the definition is always going to be at 0, 0, 0 for both of these objects. The instances is where I control where I place those in relationship to each other. So I'm going to do another model block instance and use the block definition. And then this time, what I'm interested in is the origin point, but the Z is controlled by the plate height, right? So the Z of this is controlled by the plate height. So if I go to vector and add a new construct point and use the plate height as the Z coordinate, and then use that as my transform, and then let's turn the preview off on these definitions, as well as this. Now you can see I've got one instance of a block definition called column, which is at the top surface of our base plate, and another instance called block plate, which is at the origin. Does that make sense so far? Sorry, that wasn't probably as smooth as I could have been. Can you pass blocks through transformation components like Elephant allows it? I think so. I don't know that I've tried. You mean like this type of transform?
Just like a move component, any of the Euclidean transformations.
Yeah, yeah.
Oh,
So,
cool.
Yeah. So there, I moved the block instance up.
Awesome. So the transform is really setting the base point of the block. Is that what that transform is doing in the
base point of the instance?
Right.
Of the instance. So it's like, so
okay.
Because we created the definition at the origin, right?
Yeah.
Now, whatever I move, wherever the position is for this transform is like, it says, go from the origin and move it to this new point, or the, right? And there you can even see it's saying move to 0 from 0, 0, 0 to 0, 0, 0.11, right? And so it's literally saying take the block definition, which was created at the origin, and move it to this position. And so now we have two instances, right? We have two block definitions and then two instances of each of those definitions that are located properly in space. And now from these two instances, we want to make a nested block. Okay. So we want to make a new block definition. And our new block definition is going to contain one instance of our base plate and one instance of our column. And so we can give this whatever we want, a name, let's say nested column, or whatever you want to call it. But in this case, I'll create a new block definition called nested column. And so this definition contains two instances, one instance of the plate and one instance of the column itself. Does that make sense to everybody? Because anyway, hopefully this will make sense as I start to build it along. The last thing I need to do now is to take, so now we've created a nested block, model block definition, which is called nested column. And we need to take our nested block definition and move it to each of those intersection points, like I was saying. So that's where we take these points. And so I'll use a point parameter and take this over here. And we're going to make a new instance of our nested column. So again, it's going to ask us what is the definition and what's the transform. So the block definition is our nested one and the transform. And now you can see we have a nested column at each one of our intersection points, right? And that nested column is made up of 2 individual blocks.
I have a question.
You could. The only point here was just to try to show how you make a nested block definition. You could say, I want, you know, this to go in there and this to go there as well, holding shift down. And so you can have as many objects as you want, make up a block definition, but then it's not a nested one. It's just a single block, if you will. If you want to get more fancy and have blocks inside of blocks inside of blocks, this is how you do that. So yes, you can totally have multiple objects in a single block definition. Okay, so we have now.
I have a quick question.
Okay.
Only my base plates were transformed, like the column that I connected the column and the base plate into the objects. Like attribute there. So I'm not sure.
Column should go into one and base plate should go in the other.
Yeah, like
And
then further down where you combine them into the nested column, like I did that, but then oh, never mind. I was yeah, got it. Thanks.
Okay, cool. And actually I can turn this off, all of these previews off. And because really what I'm interested in are these instances, and you can see we've got a little bit of a UI preview that we show when it's selected, which kind of shows the bounding box of each block definition that you have. So here we've got one block that's, or actually this is showing the bounding box of the nested one in this case. If you were to go back over here, for example, and turn this on, you can see it's going to show you the bounding box of that, and that one's going to show you the bounding box of that one. So it does kind of show you, and a little set of arrows which show you sort of the orientation, which is based on the transform that you give it. But what we're interested in now, we've got our nested columns, and the last step we need to do is define the names. And fortunately, we've already created the names, right? Back here. You guys remember when we did A1 and B2, B1 and so on? So we want to assign these names to these blocks when they get baked. And what we want to do is actually use a concatenate. Concatenate is just a text way of joining text together. So we're going to say this is the fragment, and we want to append the word column. Oop. Well, so all I'm doing is here is creating, like, so we have column A1 and column B1 and column C1. And so this is essentially taking this little text fragment and joining it with the result, the text that I give it here. Does that make sense? So I'm just concatenating, so I have a list of names. So I can move all of this back over here. And the same way we did at the very beginning, we can assign object attributes to our blocks. So we use a model object, and in this case, we can take our block instance if we want with the geometry. It could be in geometry or object. It doesn't really matter in this particular instance. And the name is the ones we just created, right? And I'm trying to think of why this is showing up. Oh, I think I want to flatten this. Yeah. So that's the one difference here. So that we have a list, a flattened list of 20 blocks, and we now have a flattened list of 20 names. Right. So the first one will get A1, the second one will get B1, and so on and so forth. So we need to sort of manage our data tree a little bit so that we are properly assigning things. So now if we look at this, it's going to say a very long thing that says it's a model block instance called nested column, and then the name of that is column A1. Okay, lastly, we just need to bake it. So we're gonna take the geometry and zoom in. Now, I hit true, turn the preview off on this, and nothing's in my scene. Well, but if we look over here, we now have, that should say instance, that might be a bug too. We have, this should say block instance of plate and block instance of column. And we have our top level is called nested column, right? The reason you're getting this, the invisible, is a bug that we know about. We just haven't had time to fix it. For whatever reason, there's this very bizarre little bug that is persistent in that when you bake your geometry on a layer, excuse me, when you bake geometry on a layer that is semi-transparent, those blocks don't show up. And I don't remember if I talked about that at the beginning or not. I think I maybe did. But if not, all the fix is to just make that grasshopper layer go all the way to fully opaque. And now you can see that we have our columns showing up as extrusions. And there are ways, and the reason why those are is because throughout here, we didn't really assign the geometry to a specific layer, right? So if you don't assign things, like let's say we created a circle, right, up here, and we wanted to bake that, if you don't give it a layer, it's going to create a grasshopper layer and put it on a sub layer, right? So for example, extrusions are put on extrusions. If I put this on, if I bake that, now you can see we've got curve on this curves layer. And you know, if I select that, there's the circle that was baked. It's on the grasshopper. So basically what happens is if you bake stuff without having assigned a specific layer, it's going to just make it its own layers for you to try to help manage that. You always need to use the origin. You can use whatever, so, all right, the question here was, when you make a block definition, do you have to use the origin? The short answer is no, but if you don't use the origin, so for example, let's say, let me move this circle over here. All right, so I've got a circle here, and let's say I want to make that a block definition. You can certainly do this, right? And let's just call this circle. The funky thing is when you make the block instance of that, right? So you've made a definition of a circle that is, and let me get rid of this one because it's getting kind of confusing. But so we have this circle over here, and we've moved it away from the origin. When I make an instance of this, so let's say I want to make a model block instance. This is the definition. And let's say I want to make it at here, 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 and here, right? If I move that, you can see what's happening is that here are my block instances, but it's essentially using the origin point for the block definition. So my bounding box of my circle is essentially from the origin point to the boundary of our circle, if that makes sense. And then it's taking that as our block definition and moving it to that point. Does that make sense?
Yeah, I guess that was my question.
That's why I recommend using the origin as the center for whatever it is you're making.
Can we get a custom plane input on that component?
Well, that's the thing. That actually is how Rhino works, too. So when I made that block here, right, and hit block, it is actually making it it's you taking that point, moving it over to the origin, making the block definition of the origin, but then moving it back over here for the instance. So this block, even though it says block definition, it's actually doing block definition and instance, because now we have an actual instance of this in our Rhino model. Does that make sense? And so it's kind of confusing, I get it, but this is actually how Rhino makes block definitions, is that it's the origin of the definition is always at 0. It may be different from AutoCAD, and it's very possible, I guess I could be misspeaking, but I'm pretty sure this is how this is all works. And so block definitions in this case are going to go from 0 to wherever your geometry is, and that's is what encapsulates your block definition. And then from there you can make your instance. So what I would always recommend, I mean, you could, a workaround would be to then transform, you know, your circle, move it to the origin point before you make your object, right?
Could that be built into the component though? Because I feel like we do this, like if you were to code this, you could do that. I don't know. Anyway, just food for thought.
Sure, I understand. Yeah. And it is a little confusing, and I'm open to suggestions, and it might be something we look at.
Yeah, I mean, I get how it works. I think it's just like from a usability standpoint, I don't want to have to move it to the origin every time and then like work around that.
I mean, for me, what I would recommend is the definition is like the component, right? The individual unit. So I would always recommend working at 0 for that component. And then when you're ready to make the instances, that's where you start to move it around to all the different places. And so the individual unit, I would just recommend when you're defining the unit or the definition, you keep it at 0, and then you move it around for the instance, if that makes sense.
Yeah, that makes sense.
The insertion point is essentially the transform. The insertion point is like moving it from the origin to each of the insertion points. So when that says the block, when you hit block and it asks for the insertion point, that is this transform position. And that's why I say, like, it's better to make it at 0. Then you set the points and it moves it exactly to where you want it to be. Hopefully that all makes sense.
Makes sense. Yep. Thank
So
you.
here we have a column whose name is now B1, right? And this one is going to be C4, and this one is A4. And so all of our data is now updated and choreographed, and we know all of it. We've assigned metadata because we know the name and position within the location. And so, as I said, now what's interesting is, again, we can take this and update it. And because it's, you know, remember we talked about the position where the query model objects, everything downstream from that is happening. And so again, we can rotate this, and any of the intersections it finds along these lines is where you get new columns. But this one still knows it's C4, right? This one still knows it's C2. Once I hit solution recompute, it jet snaps back. And like I said, it's fully parametric. So jumping back over here to the very beginning, and changing the number of sliders still works, right? So now this is still F3, right? We have column F3, and this one is G1. So
what happens if you move the column in Rhino with the gumball?
that one snaps back because it's being forget exactly. I think because so this circular every time it's coming from this query component, just filtering the lines and downstream. So it's triggering, and you could do not update automatically. So then it would.
Yeah.
But
okay.
You update it, it will snap back.
Yeah.
Cool. Okay. Surprisingly, we did really well. You guys were really sharp. I don't know if you were able to follow along or just watch as I did some of the stuff, but I really hope a lot of it made sense. And what I'd like to do is, I guess, open it up. We covered most of the things, I think, here, but there's probably stuff that I glossed over. But I'd like to open it up and ask for any questions, and we can kind of work through some things from there.
Can I ask another quick question? So this seems in general like all of this existed before for Grasshopper geometry, but now it's all been ported to edit Rhino geometry, all the baked stuff. Is that accurate? I mean, along with all the other like filters and additional things.
Actually, no, none of this really, none of the attribute stuff existed.
Right.
Like
yeah.
you have a curve, right? Curve parameter, and I make a circle out here, and I reference this in. This thing doesn't know that it was created on, let's see, on the default layer and has a black layer color, and like it only knows that this is a circle. Whereas since Rhino8, since we added that in, now if you use the model object parameter, so we recommend using this as a parameter. So I recommend either using the query model object or this query model parameter for bringing objects in. But if I were to set one model object, now this does know about all the layers and everything else. Does that make sense?
Yeah, that makes sense.
So really, to me, it's a completely different way of opening things up, because before it really was just geometry. Now we have understanding of all of the different attributes, annotations and hatches and all of that other stuff. But we now know, like, the objects themselves contain all of the additional data that this one just really did not. Even though they look the same, this one has a lot more information attached to it, right?
Right. Yeah.
So this is reference circular curve. This is a reference model object, and this one contains a lot more information.
Right. Okay. Yeah, that makes sense.
So there was a question in the chat. Two questions. One, the first one was, will you give other Rhino8 workshops? I guess yes. I don't have any planned, and I don't know if there are other workshops planned by other internal team members. But my hunch is that yes, of course, we'll be giving additional workshops on this stuff and even more, so new features and stuff like that. This is specifically Grasshopper related features, but we've added a whole bunch of other Rhino related features that we just didn't cover. Shrink wrap, for example, actually has a Grasshopper component as well, but there's a feature called shrink wrap here. And what that lets you do is essentially take really gross geometry. It could be B-reps, it could be meshes, it could be whatever you want. and it could be malformed, it could have holes in it, it could be whatever, and you can shrink wrap it and get a very clean watertight mesh out of it. And that's a feature that you can read about on the Rhino stuff. Not really something we cover here, but it is something that is really powerful. And so there are a number of other Rhino 8 features in general that are available that we encourage you to kind of look at the feature list for Rhino 8. The second question was, is it possible to also query detail view objects for more page layout control? Okay. No. The short answer is yes and no. So yes, you can query objects on detail pages, but we have not finished all of the detail layout control. So what I mean by that is, if I were to show our parameters, there is a page filter which lets you filter for like a layout page, right? So I could say, now there's nothing in it, but I could go in here and say page 1, right? And it would query objects that are on page 1 that also match whatever filters I have here. So you can query objects for that, but we don't yet have, or we haven't exposed yet, the ability to bake to a detail view, for example. It is definitely on our to-do list. You do have certain things here, like you can query pages. So here I can get the page, I have one page. If I add a second one, now you can see I have 2 pages. So there are things we've started adding, that we have like a data type for page views and things like that. But there's more tools that we want to add that are coming that will allow you more control over like baking to a detail view and having more control over stuff that happens in a detail view versus model view. And so that's definitely coming, but it's not there yet. So I don't have that fully, it's kind of halfway there, right? We have some ability to control querying, but not enough to really give you full control over like baking to layouts. But that's a really good question, Adam. Have a workshop about ControlNet and AI. That's probably outside of our domain. The question was whether we have a workshop about machine learning or artificial intelligence, I think is kind of the question. You'll notice that in Rhino and Grasshopper, there are no machine learning or AI tools. We are busy enough just trying to keep up to date with the tools that we're developing and the features that we're developing. We're not a big enough company to really throw a bunch of resources at something like AI or machine learning because it's such a fluid field. That said, there are third-party plugins. We try to make it open enough to where people can develop their own machine learning plugins or AI tools, and you can use those. And so there are plugins that are out there. So if you haven't explored the package manager, is where a lot of where you can download and access third-party plugins. And so, for example, one that you can do is Lunchbox, I believe. It has, I think this one has machine learning, right? So there are, and I actually worked on some of these before joining McNeil. So I know a little bit about this particular plugin that has some machine learning tools. So you could install that, and then you would get a new tab called Lunchbox ML, and it would contain other components. But we don't really internally have much experience with AI. I have a little bit of background in that domain, given my background and my doctoral degree. But in general, we are kind of watching to see how the field evolves, because obviously there's a lot of new technology out there and it's changing quite rapidly. And so we kind of wanted to see, where things are leading before we just jump in full force. So if you're really interested in AI or machine learning, I think I would probably recommend looking for workshops that are being taught. And in fact, I think there is a Lunchbox workshop that's being taught specifically for machine learning topics. So there are people that are developing their own plugins and teaching their own workshops. That's right, next week.
That's right. I was gonna make a little plug for that. Yeah, next week the in-person workshops on the Thursday. We got
Perfect.
Nate Miller coming over for, as you say, lunchbox, and Omid, one of our own, doing a full day introduction in machine learning and how within Core Studio we're starting to use it on projects, etc. So
yeah, so I would recommend
more coming.
those, but as a company, we do not have much in the way of that. It's not to say we won't move that in that direction, but at the moment we don't even have AI tools or anything like that that we could even do a workshop for. So I would look at the third-party plugin developers for that. What else? I probably went a little fast because I thought I would for sure go over 5 o'clock. And here it is, we have 15 minutes. I don't know that I can show section and clipping. Jaffe, would you like to show section and clipping? Do you have something you want that you could show?
Is the clipping plane now available in Grasshopper as well? Let's say controllable by Grasshopper, or
no? And so that's
it's still a Rhino thing.
That's why I was wondering. So there is a whole bunch of new sections and creating section tools. It was being modified really late in the game in terms of a lot of things were changing in how those were being created and the attributes for those and so on and so forth, that we decided we were going to let that kind of settle, meaning me, Kike and I, who are developing the Grasshopper stuff, and we had tons of stuff we needed to add anyway. So it is on our to-do list, just like lights, I think, is another data type that we haven't supported. Section tools is a big one, obviously, that we want to add support for. And then other things like detail view and detail as that kind of data type, as we mentioned. Another big thing we eventually want to do, and it's a much bigger project, so it wasn't something we were going to try to tackle for 8.0, but is essentially some sort of control for materials and shader control and mapping, UVW mapping, and things like that. So there's a number of data types that are associated with rendering and materials that we think could be really interesting, being able to create parametrically controlled materials and shaders and things like that. But that's a really big project. And so I think once we wrap up some of the stuff that we have remaining, like we really want to finish off most now of all the data types that are available in Rhino, except for, like I said, lights and what else? Section tools and things like that. Once we wrap that stuff up, I think we're going to start shifting ideas for the next stage of this development, which would be probably materials and rendering and things like that. But Jaffe, if you have anything you want to show on the section and clipping, I'll definitely let you switch. Is the taper curve just a display setting or a curve property that can be printed? That's a great question. And again, maybe Jaffe knows more. It definitely can be, okay, he's in a meeting. You can definitely print them. So you can also assign, so let me just move over here and let's create a new, tips. All right, so what we can do is make a new one, and okay, what, I'm going to go through this way. Line type. So I can look at the one I just created. And let's say we want to do tapering and we want to, the taper width is 10, and the end width is 1, and the start width is 1. So it's going to be 10 in the middle, 1 in either of these. We click OK, and then I assign this to be our custom line. So here you can see we've got our line and it shows up. And now let's say if we print, I'm pretty sure, yeah, it prints with it will print with the line taper there. And I think we even have, I think there are ways, I have to double check with Steve is the one who's really put a lot of work into this. I think you can even get a vector output from this. So it doesn't even have, I think it will actually find the vector outline of the taper. It doesn't just have to be a pixel representation. It can be, obviously. Yeah, here. So you can do vector, raster, or vector. And if you do vector, and you save it to like a PDF or whatever, it will actually vectorize this taper. And so it's pretty interesting. There's a lot of things you can do with it, but yes, you can make line types and it will print.
It's awesome.
Yeah, it's a neat feature. And like I said, now your line types can all be, I mean, you can set them through here, right? The way we just did, but you can also control them in Grasshopper, right? So now these things can be fully parametrically controlled. And when you bake it, it will update the thing in the line type table.
Even better.
What else? Any other questions? Again, I would recommend looking at the feature list for Rhino 8. Section tools have been highly updated. So these sections where you can create new sections, there's, I'm sure, let me see. I don't know if there are any. Like, put it in a section. Let me see if there's any guides. Okay, maybe not. I thought there were some guides that were already available for sectioning. It looks like they're sort of in progress, so those might not be there, but there are. Let me check and see. There have been some discourse posts on other features. So if we go to no, that's not it. But there are, and I should probably be able to navigate to it better, but there are new section tools. With some more information about how they work. And unfortunately, I'm drawing a blank on where to find those actual tools. But I would recommend kind of looking at section tools. There's shrink wrap. There's a whole bunch of things that you can actually. So this is a post that I made on Discourse that talks about basically the user attributes and things like that. But Rhino WIP features here. Here is the, I'll put it in the chat. This is the current feature list for Rhino 8. And so I don't know, let's see if I can find a section. Yeah, so sectioning is now pretty cool. You can create section objects, which will actually then be able to display various types of hatches depending on how you set the attributes. So they have section styles. And so this is all the stuff that will be integrated in Grasshopper, which is why it's like a totally new data type. And it was changing, a lot of the stuff was changing, which is why we didn't quite have it yet. But eventually you will have a section tool, a section data type, and that section data type will have section style as an attribute. And so there's really a lot of things you can do with sectioning that I think is pretty cool. And I would, recommend kind of looking at some of these new features. But in general, you can also look here at all the stuff. There's been a lot of stuff that we've added in terms of mesh shrink wrap. Here's the shrink wrap feature that I was showing, where, I don't know why it's loading so slowly. But shrink wrap is also really interesting, lets you create some really watertight meshes for 3D printing and so on and so forth. So it's a really clever tool. And again, I don't know why it's taking so long. Any other questions?
Not a question, but I think I figured out why your nested blocks weren't named, which I think is they need to be baked with those names and then queried back in. At least that's what I'm seeing. Like if I create a name for the nested block and bake it to columns, the columns are on there. But so even if we named base plate and column, that stuff is not carrying through to the nested blocks.
I see what you're saying. Yeah. So what I noticed in this is that so this is what I was saying, it's kind of like a bug, is that actually you see it's actually updating the name, or if I actually change certain things, but you're right, and then there you can see it actually stayed, right? So we have an instance of a column, so it's possible we have a bug in there, but I do have an updated file, which I didn't show. Let me close this and close all of these actually. And if you want, I will happily add this to the Google Drive. But let me open so here we have our base definition, and I'm going to go open this file called updated. And it's the exact same file that we had before. The one difference is that I have changed the last little part. And so what I'm doing is I've created the base plate geometry. I am assigning a name called plate and a layer under column plates. And same thing here, I'm doing core and columns core. And then the block definitions also get assigned, or have this column plates and column core. Then the last thing is we provide a name for our block definition called column, and then also a layer called columns for our final block instance. And when we do that, it's a little bit cleaner. Here you can see we don't get that grasshopper layer, and we don't have to deal with that layer color issue with the transparency bug, because creating layers with default black, and you can turn off the cores or the plates because those definitions are stored on those sublayers, and so it's a little different setup. Only reason I didn't go through this one was because I had already uploaded the other one, and then this one today. And so this one I can upload, which has just a small little update to it, but that it's a little bit cleaner, right? We don't have that grasshopper, the automated grasshopper one, and also now we also have interesting. I thought that would fix we still have basically columns and we have base and stuff, but I thought, see if we, there we go. So oddly enough, something about changing the slider we have a block definition called column plates, a block definition of column core, and then a nested one called column. And you can see it's nested because we have, the first one is,
Yeah.
and so anyway, we have definitions, and then we also, and then it shows also plate and core as the sublayer of the geometry, has a name. But so anyway, something about it we may need to look into is like a bug about why we're getting this one weirdness about. But I do like this definition a little bit better because it's putting things, the definitions and stuff on their own layer, so you can actually control. Do you want all of the columns off, or do you want just the plates off, or just the columns off, and so on. And it's not that much different. It's just a little bit different in that we're adding like this little bit before the definition, and then this little bit before the nested one. And then a final thing is we're adding a layer to this part. So it's just a couple little tweaks, but it does kind of help a little bit on some stuff. So I will add that to the Google Drive folder after the workshop here in just a second. And if you want to pull it down and use that, I would say this is probably the most up-to-date final document that I think it would be useful.
Great, thanks.
Okay, obviously you guys can reach out to me at any time if you have any questions. You have my email. I think I'm also on the Slack channel, so if you have questions, you can put it there. I'd love feedback, good, bad, or otherwise. I'd love to know if this was confusing, if it was too fast or too slow, or you knew most of it, or you didn't know any of it, and you couldn't follow along. All of that stuff is good feedback, so that we can make it better the next time. So any feedback you can give, I would appreciate. And otherwise, I hope you guys learned a lot, and hope you guys get to use it more in your workflows. All right, I'm going to sign off now and stop sharing. And I hope you guys have a good rest of your weekend.
Awesome. Thank you so much.
Thank you so much.
Thanks. Very nice.
Thanks, Andrew.
Thank you.
All right, bye guys.
Bye.